Hello and welcome back to my channel, guys. In this video I'll be talking about rolling margin. So this is a very important term that is usually used on construction sites. We'll see what is the importance of rolling margin and what it actually is. So by definition it is the deviation of actual unit weight to the standard weight of steel as per IS 1786. So let's see what is the unit weight. Unit weight is the length of the weight of 1 meter length of the bar. So if 1 meter length of bar is W1, the standard weight of bar is given as D square by 162, and let's say this is W2. Now that percentage deviation will be W1 minus W2 upon W1 into 100. Now this is the percentage deviation which is given in the IS code, and the tolerance limits are also given. It can be minus percentage deviation or positive percentage deviation. So let's see what is the importance of rolling margin, why rolling margin test is done. So basically what happens during the manufacturing of steel bars, a die is used for casting the bars. Okay, now the die has a certain diameter. The diameter of the die, the internal diameter of the, so suppose this is the die, the internal diameter of the die will be equal to the diameter of bar that is being manufactured. Okay, now during the course of time this die will get eroded due to using it again and again, and as a result of which the internal diameter of the die will be slightly larger than what it was before while it was used. So as a result of which the diameter diameter of bar that will be manufactured with that die will be slightly bigger. Okay, and if that diameter is bigger, if put D over here, that increased diameter, the weight per meter you will get will be greater than the standard weight of the bar. So let's say for example, for 10 mm bar, the standard weight of bar will be 10 square by 162, and it will be 0.62 kg per meter. Now if the diameter of bar is slightly greater than this, let's say if it is 10.32, then the weight of the bar will be 0.65 kg per meter. So you can clearly see the weight per meter of the bar is increasing due to this. Now why this is a problem? Now what happens, a client or a contractor, they order the steel in terms of quantities in kgs. Okay, as a result of which they will get less number of bars in the bundle than that is required. Okay, the bars come in bundles, so if the weight per meter is larger, then the number of bars in the, or the length of the bar also will be lesser than what they were expecting. For example, for a girder, okay, the girder will require a bundle of 10 bars of 12 mm. Okay, but if the die was eroded and the diameter of the bars that were casted are slightly greater than that, let's say it was 12.5 mm. Now due to this problem, the number of bars in one bundle will be less, and for preparing the girder, for preparing the reinforcement cage for that girder, the number of bars that will be required will be less. Let's say if it was only 9 in that bundle, so you will be falling short of 1 bar for making that girder. Okay, now also, as you know that the weight per meter of the bar is increasing, the length of the steel bar that you are ordering will be less. So let's say for example you had ordered 40 tons of steel, so 40,000 kgs of steel you ordered, and the standard weight of 10 mm bar is 0.62 kgs per meter. So the length that you should receive will be 64516 meter. This should be the total length of the bar that you should receive, but due to the rolling margin error, if you receive 10.32 mm diameter bars, then the weight per meter will be 0.65. Now when you are ordering 40,000 kgs or 40 tons of steel, then in this case you will receive only 61538. Now clearly this one is greater than this one, so you are falling short by 64516 minus 61538, which will be equal to 2978 meter. So you are falling short of almost 3000 meters, but the price you are paying for the steel is same. Okay, so this will be a problem when you, because you have already done the quantity survey for the entire building or for the entire construction site. Okay, and you had already calculated the length of bar that will be required, but when you ordered it, you are falling short of 3000 meters. So this length of bar you'll have to order again, so this will eventually increase the cost of the project. So that's all is rolling margin. And I told you how to calculate the percentage deviation. Now we'll see what are the tolerance limits that are given by the IS code. So if you refer IS 1786 2008, it's given in clause number 7.2, referring to nominal mass. Now the tolerance limits are different for different diameters of bar, and up to and including 10 bars, the tolerance limit is given as plus minus 7%, and about 10 and up to 16 the tolerance limit is plus minus 5%, and over 16 the tolerance limit is plus minus 3%. So that's all about rolling margin. I hope you understood this important topic, and if you have any doubts, please comment down in the comment section below, and please don't forget to like, share and subscribe to my channel, and till then I'll see you in the next video.